Good morning. I'd like to go over question 12 on section 3.2, which goes over this. This is a pretty typical situation. We've got height of a ball, which is going to be represented in feet, thrown by a child, represented by this equation here. So it's y equals this negative 1/12 x squared plus 4x plus 3, where x is the horizontal distance from the point which the ball is thrown. So if we look at it, here's our situation here, where here's the ball. The kid is going to be the y-axis up to that point, and the kid's going to throw the ball, so it's going to go like this, and off it goes until it hits the ground, just like that. So the things we need to remember here is that our inputs and outputs are this, right? So our horizontal axis is always going to be the distance that the ball has been thrown, right? So as we move along here, this 10 represents when this is 10 feet away from the child after it's been thrown. And then the vertical axis here is going to represent the height of the ball at that time. So, we can see that the height of the ball is increasing until it gets to its maximum right here, and then it's going to start decreasing. It's going to have to come back down to earth. So as long as we kind of keep those two variables in play with it, then I think it would be really good. Instead of y, I'm going to use f of x here, just because I think it's good practice to do that. So x is going to be this horizontal axis here, and then f of x is going to be my vertical axis here. Let's go ahead and get to questions. So the first one is, how high is the ball when it leaves the child's hand? So, right, if that's the vertical axis right here, if this is the moment that the ball is thrown, then this is the same as asking, well, when is this ball going to be 0 feet away from the child? When has it been thrown 0 feet from it? So the moment it is thrown out of the child's hand. So that would be plugging in a 0 wherever we see an x here, which gives us this, and then 0 times anything is going to give us 0. So this whole block here, this one right here, is going to be 0, and that 4 times 0 is a little easier to spot. That's 0 as well. So we end up with 0 plus 0 plus 3, which turns out to be 3 there. So the height is going to be 3 feet. Go to question 2 here. What's the maximum height of the ball? So this is a really nice question to have a visual of, because we can visualize where that's going to be. We can see that the ball is going to go so high here, and then it's going to start to decrease here. So the maximum is going to have to be somewhere here, somewhere between this 20 and 30 feet away from the child there. So so the way to find that is to use some properties about what we're looking at here, what this represents, right? The graph is a parabola, so it comes from a quadratic equation, a polynomial with degree 2. So when we're looking at that, any quadratic can find its vertex by using this little formula here, which is part of the quadratic formula, the negative b over 2a. In this case, our a is negative 1/12, our b is 4, and our c is 3 there. So if we need to figure out what negative b over 2a is, well, that's going to be the same as negative 4 over 2 times negative 1/12 there. And we can sort this out. You can see Desmos is doing it for me, but I want to make sure we kind of take the time to know how to do this, because it's easy to goof something like this up if you're just doing like a pen and paper type situation. So do what's on the bottom here first. So this 2 times negative 1/12 is going to give me negative 1/6. And the thing to remember about that is this is negative 4 divided by, this is how this was originally grouped together, this negative 1/6. So it's negative 4 divided by negative 1/6. This is what's called a complex fraction. So how it's originally grouped matters in terms of how you distinguish how it's separated. So this negative 4 divided by negative 1/6 is the same as saying this is negative 4 times, and if we take the reciprocal of that, 6, then we can sort that out. That negative 4 times negative 6 is 24. So we know that the ball was 24 feet away from the child when it was thrown. So we want to know, well, at what height is that? So if this is, say, 24 here, how high in the air is that? We can find it in feet here. So that would mean plugging it back into our function here. So that would be, say, f of 24, which is that negative 1/12 times 24 squared plus 4 times, this was an x as well, 4 times 24 plus 3. And I did something a little different here just because I didn't want to be dependent upon my calculator so much. I know I'm using it right now as a reference, but I wanted to be able to sort it. And the way I thought of it was this 24 squared is 2 multiples of 24. So I took one of those multiples of 24 and I divided that by 12. And that left me with this negative 2. And I also had the second multiple, so this ends up becoming negative 2 times 24 here. And then this 4 times 24. And then I did something else. I went, well, these are groups, so I have negative 2 groups of 24, and I have 4 groups of 24. So if I were to combine these together, that would give me 2 groups of 24. So all of this ended up just becoming 2 times 24, or 48. And that 48 plus 3 is 51 there. So again, just a quick review of this functional notation. So the ball is at its maximum height, or the vertex of the parabola is when the ball is 24 feet away from the child. It is 51 feet in the air. So since it's asking what is the maximum height, that's our 51. That is like the height piece of that. And our last question here is, how far from the child does the ball how far from the child does the ball strike the ground? Okay, so if this is our scenario, we can see that the height of the ball is moving along and it'll hit the ground at 0 here. We're assuming that the horizontal axis is the ground. I think that's a fair assumption. It's not on, say, some hill and it's going into a pit below 0 feet here, so the height of the ball ends up becoming negative, like it's depicted in this animation here. Let's say it's when it hits this horizontal axis. That seems to be what we're after there. And if we were to do that, well then what that means is we essentially need to find x, so find out how far away from the child it is, when y, which I've renamed f of x, is 0. So solve for x when y or f of x is 0. So that's the same as taking our function, right, this function way back here, and then setting it equal to 0. Now if we had this, what I would do is I would send this through the, well, I would try to factor it, and when I did, that negative 1/12 just ended up being a bit of a problem. So what I ended up doing instead is I sent it through the quadratic formula, which is this here. And the only thing is, the program I'm using here, Desmos, won't allow me to use plus or minus signs here. So I just wrote plus there, but we need to remember that it's actually plus or minus there. So I wrote myself a little note there to remember that. And we know, right, so if we were to send this thing through, then that means b is 4, so this would be negative 4 plus 4 squared minus 4. A is this negative 1/12, and then c is 3. All over 2 times, here's my a, which is negative 1/12 once again. Now again, it's going to spit out an answer with it, but I actually think that's not a good way to do math, right? If you just kind of trust your calc, it might do something wrong. Like, for example, forget that this could be plus or minus there. And then negative is not what we're after. So let's continue with the problem and see where it goes. So the first thing I did is I took care of this 4 squared. So I looked within this little grouping here, and then within it, this is the first thing that needs to be done. So that 4 squared is going to give me 16, and then everything else stays the same with it. And then once I had that, then I did the multiplication. So I took care of this part. So for example, I did the 2 bigger numbers first. So this negative 4 times 3 gives me negative 12. And I'm glad I did, because that negative 12 times negative 1/12 just turns into positive 1, so this whole block here turned into a plus 1 on it. So that made that a lot nicer to deal with. So since that was already sorted, then I went back and I went, okay, well, what is this? This is 2 times negative 1/12. That's just going to give me negative 1/6. And that made me feel okay, too. So I'm still living within that square root, and I can see that that 16 plus 1 is 17 here. So I have this in my numerator, negative 4 plus, remember, it's negative 4 plus or minus the square root of 14 here, divided by this negative 1/6. And this divided by negative 1/6 is no fun for me, so I then changed it to multiplication, so it was like negative 4 plus 17 divided by negative 1/6, and then I changed it to times, flipped it, negative 6 there. So this is the point that that is interesting, because again, remember, this plus right here is actually a plus or minus. So if I were to distribute this negative 6 through, it would still be a plus or minus there, because, well, frankly, it doesn't change anything in there. So we end up with 24, either, just to keep it consistent with what Desmos is giving me, if I were to send that negative, so it would be minus 6 and the square root of 17. And if it was a minus here, then it would be 24 plus 6 root 17. And when I send those through, that gives me this negative 0.738 business here, which is this part. So it's before the ball is like thrown out of the kid's hand. Let's assume that like this is starting where the kid is here, and then it's thrown like this. And the second one gives me 48.738. Well, again, I can use this graph as a way to kind of reason out which of these is it after. And I can see the ball is going to end over here fairly close to 50 feet away from the child. So I believe this is going to be a better answer for me. So I'm going to take that. I'm going to put that right there. So those are those 3 pieces. I hope this was helpful. By all means, if there are any questions, please let me know, and have a good day.